My area of study was on population growth in Australia. The scatter plot on the screen shows the population of Australia over the past 10 years. As you can see, there is a clear, strong positive linear correlation between the years and the population increase. My prediction is that the population in Australia will continue to rise, but at a faster rate than the trend, because the current population is rising at 300,000 each year, but we can estimate that by 2050, the population of Australia will increase by 500,000 each year, according to the trend line over the past 10 years. Few factors that would affect the growth in population could be the large number of people migrating to Australia and increased fertility rates. This prediction is not 100% reliable, however, because I am extrapolating my prediction, meaning the data doesn't exist and my prediction lies outside of the existing data range. I'm making predictions based on the previous data I have over the last 10 years, which also means I am inferring how the data will change over time.
Hi, my name is Brandon and my topic for this inquiry is about water self-extraction in Australia. It is the process in which water is extracted from a raw water source, such as from flooding, rivers, and etc. This water can be used as fresh water after it's been treated. As we can see on the scatter plot, the line of best fit has a weak positive linear relationship. It is determined that extrapolating prediction of extracted water by 2050 is said to reach 95,236,610.69 megaliters. Influencing factors include population growth and the demand for fresh water in Australia would be increased. Therefore, more water would be extracted from water supplies and to be used for the public. The population of Australia would need this water for drinking, cleansing and hygiene use, such as showering and dishwashing. The data is somewhat reliable because the source is from the Australian Bureau of Statistics. However, these numbers could change if one state in Australia was to extract more water than the others. On the scatter plot for Victoria, the line of best fit shows that it has a weak positive linear relationship. By 2050, 23,185,823.09 megaliters of water would be self-extracted. Just like the other plot, the influencing factors of this extrapolating prediction would be inflicted by the increasing population in Victoria, and that the public will request more fresh water to be self-extracted. This statistical data is more reliable because the data focuses on one state and doesn't include other state numbers, which can play as variables and alter the statistics. Overall, this is not sustainable because Australia is extracting an increased rate of water every so years from fresh water sources and will soon run out. As for our water sustainability, Australia needs to implement a better water cycle system that can be used for drinking. Therefore, the nation is not required to self-extract as much water predicted by 2050.
The topic for my graphs is global sea level elevation. These graphs display the total global sea level elevation. Basically, this indicates how much the sea level has risen over time. The graph for the first 10 years has a positive linear trend line. It is predicted that with linear regression line formula, by 2050 the sea level will have increased to 154.85 millimeters. The graph shows that in 1993 the sea level has risen 6.6 millimeters from the original sea level height, and in 2002 this has risen to 32.6 millimeters. In the graph indicating the latest 10 years of sea level elevation, the graph also has a positive linear trend line. It is predicted that using the linear regression line formula, by 2050 the sea level will have risen to 229.28 millimeters. In 2009 the sea level has risen by 53.5 millimeters, and in 2018 the sea level has increased by 86 millimeters. What this means is that without any change made to reduce the amount of sea level elevation, by 2050 many cities like Miami, Venice, Bangkok, New York, and more will be underwater. This will also wipe out many animal habitats and many animals displaced from their homes. the amount of usable land will be reduced, harming infrastructure and agricultural efforts.